Imagine for a moment that the body you live in is not simply a collection of cells, organs, and biological systems, but rather a vast and intricate network, something like an invisible internet woven out of living tissue and chemical signals. If we look closely enough, we could begin to notice patterns that strongly resemble the way information technology operates, almost as if beneath the skin there flows a code written not in electricity and silicon but in molecules and memory. Within this strange perspective, there lies a fascinating and unsettling hypothesis. What if viruses, the dreaded invaders of the biological world, are not enemies in the traditional sense but could instead be interpreted as data packets, the same way that computers send and receive information every millisecond across the web? The idea sounds extraordinary, almost like a piece of speculative science fiction, and yet it asks us to rethink the very meaning of life, disease, and interaction on a molecular scale. This thought experiment is not meant to frighten, but rather to open the mind to new possibilities, letting the imagination drift into a space where biology and technology fade into one another, where the laws of the living and the codes of machines become interchangeable languages of communication. As you absorb this idea, allow your mind to slow down, to picture the body as a vast map lit by circulating information. Every heartbeat is a pulse, like the rhythmic blink of a server light in a dark data center. Every breath is an intake of fresh signals, oxygen molecules carrying coded instructions into the bloodstream. The millions of cells inside you are like silent terminals, each waiting with hungry patience for packets of meaningful data. In this enormous and ceaseless exchange, viruses may not simply be dangerous stowaways. Perhaps they are fragments of information, coded messengers arriving uninvited yet bringing along a script that the system must decide whether to run, ignore, or resist. Imagine a world where infection is not merely invasion but a transaction, where a virus is nothing more or less than an unexpected file attached to the ongoing narrative of life. The imagery may at first seem abstract, like dream logic hovering at the edge of comprehension, but it holds an elegant symmetry. When a data packet moves across the internet, it contains a payload of useful or harmful instructions, wrapped up neatly in a protective envelope. The packet cannot deliver itself without passing through a host of routers, servers, and networks, each of them checking, translating, and forwarding the message in pieces until it finds its ultimate destination. In a strikingly similar way, a virus is also nothing more than a set of structured instructions written into the code of nucleic acids, stored inside a shell of protein. It cannot live on its own. It must rely on available hosts, cells, and living systems, borrowing the machinery of others to pass along its instructions. What this comparison reveals is that biology and information science may be two branches of the same tree, expressions of a deeper principle of encoded messages traveling through open channels. As you let these ideas drift over you, you may notice how natural it feels to see the world through the lens of communication. Life itself, after all, can be described as an endless conversation. Your body is having a constant dialogue with itself, cells whisper chemical messages, organs signal their needs, and neural pulses flash with urgency and clarity. In the midst of this chorus, what we call viruses could be thought of as strange letters arriving in a mailbox. Some of these letters may be harmful, containing instructions that disturb the peace of your home. Others might be neutral or even beneficial, teaching your system new skills, offering new perspectives carved into code. If viruses are data packets, then perhaps the way we view infection transforms from a simple war of attack and defense into a more nuanced exchange of messages, a negotiation of information flows. Close your eyes and breathe slowly, imagining that each moment of life is just part of an endless stream of data flowing back and forth. Every photon falling on your skin, every sound entering your ears, every heartbeat sending ripples through your veins, all of these are data packets too, transmissions that your living system must interpret and act upon. Within this greater sea, viruses become no more alien than an email suddenly arriving in your inbox. Some are spam, some contain risks, but some may also carry unexpected utilities. They ask not only how you defend yourself, but also how you interpret, adapt, and evolve. Just as the internet evolves by handling floods of information, filtering what matters and discarding what does not, so too does life adjust, absorb, and reorganize itself around coded experiences. The thought that viruses might be packets of data whispers a larger possibility. What if life itself is a form of computation? In silence, picture every living thing as a node, a point of networked awareness connected to all others through endless streams of messages. The forest, the ocean, the atmosphere, all humming with signals too fine for the ordinary eye to see. Within the bloodstream of Earth, viruses flow like stray packets jumping between domains, reshuffling genetic codes and histories. Some might tear down systems, but others might allow entire species to grow stronger, to archive solutions to future problems. From this perspective, what seems destructive may also be instructive, a deeper layer of the same conversation that life has always been having with itself. Allow the rhythm of this narration to slow your mind, drifting gently through images and metaphors that stretch out like a horizon. Think of your mind as a vast network too, where thoughts arrive as packets, sensations flow like streams of encrypted signals, and memories are simply archived files waiting for retrieval. In such a design, the brain is not only an organ but also a server, and dreaming could be the mysterious background process that keeps the system optimized, reorganizing files, clearing away corrupted data. If this analogy holds, then encountering a virus is not unlike receiving an unexpected piece of software that tries to install itself without permission. The struggle of the immune system is the countermeasure, recognizing malicious code and removing it before the entire architecture suffers collapse. With each passing moment, the metaphor deepens, and what began as a strange hypothesis becomes something strangely natural. The border between the organic and the digital fades, and soon it feels almost inevitable to see biology as technology, to see cells as processors, DNA as hard drives, and viruses as incoming data files. The truth may be far more complex, but the simplicity of the metaphor is soothing, carrying with it a sense of unity and coherence. Rather than two isolated domains, life and information become one thing, endlessly tangled, endlessly exchanging. So when you next imagine viruses, perhaps do not see them simply as enemies. See them instead as carriers of messages, data packets flowing through the network of life. Some messages inspire growth, some create chaos, some prepare you for challenges yet to come. Every message is part of the ongoing data stream, and you are not apart from it but within it. With every heartbeat and every breath, you too are a transmitter, a receiver, and a translator, beautifully entangled in the endless ocean of messages. When we begin to compare viruses to data packets more closely, the metaphor grows ever more compelling and evocative, opening doors into hidden parallels that most of us never stop to consider. In the digital world, a data packet is a fundamental unit of communication. It is a fragment of information broken down from larger messages, wrapped in a header and footer, ready to travel across a network, hopping node by node until it finds its destination. Something almost identical occurs in biology. A virus, stripped to its essence, is nothing more than genetic information sealed in a protein shell, waiting to be transmitted into a host cell where its code can be processed. The resemblance is more than poetic. It feels structural, as if nature itself has been deploying a universal architecture for communication, recapitulating the same patterns in silicon networks and in biological webs, as though both had sprung from a common principle written deep into existence. Take the anatomy of a data packet. It carries a payload, perhaps a small portion of a file or a sliver of an email. Around this payload is metadata addresses, checksums, fragments of identity that ensures the packet arrives correctly, that the system knows how to reassemble the message once all packets have been received. A virus does much the same thing. Its payload is its nucleic acid code, strands of RNA or DNA, meticulously shaped through evolution. Around this code is the capsid, a structured shell of proteins, sometimes enveloped further in lipids, each fold and spike functioning as a kind of address label or access credential. These features help the virus locate its host, deceive its defenses, and insert its information where it will be read. Both the digital packet and the viral packet exist not as independent entities but as carriers, designed to rely on the infrastructure around them to accomplish their task. Both live in the in-between, unable to act except when woven into the surrounding web. When a packet travels across the Internet, it reaches Reuters intermediate points that serve as gatekeepers, forwarding the packet according to its addressing instructions. These Reuters decide the direction of travel, sometimes blocking the packet if the information looks corrupted or unauthorized. Consider now what happens when a virus enters the human body. It does not instantly succeed. The immune system stands as countless Reuters, checkpoints, and defenders, evaluating the signals, examining the shapes of proteins, checking whether the information should be allowed passage. Just as a packet of malicious code may be blocked by a network firewall, so too may a virus be destroyed by antibodies or interferons before it ever penetrates a cell. The symmetry is haunting, soothing in its neat precision, yet deeply mysterious. It suggests that what we call infection is in fact another form of routing, another message navigating checkpoints, pushing its way through the firewalls of flesh. Imagine the cell not simply as a unit of life but as a workstation, a complex processing terminal. Within it, ribosomes act as interpreters, translating genetic scripts into proteins, following instructions with mechanical precision. The nucleus holds the master storage system, the operating system of DNA wrapped in spirals. A virus, having slipped past defenses, deposits its payload into this workstation. Suddenly, the cell's machinery, like a compromised computer, begins processing instructions it never intended to run. The viral code takes over not by brute force but by persuasion, by slipping scripts into the interpreter's queue. In computing terms, this is not unlike receiving a corrupted file that embeds itself into the operating system, rewriting directives, redirecting resources. From this perspective, the terrifying elegance of viral infection reads much like the logic of a software exploit, exploiting vulnerabilities, redirecting flows, consuming bandwidth. What this metaphor opens inside the imagination is a shift from enemies to languages. For a moment, let your thoughts float gently around this realization: a virus is not alive in the way cells are alive, for it has almost no machinery of its own. A packet is not alive either, but it carries life of a different sort, the life of instructions, messages, blueprints of potential actions. When seen together, they reveal a third essence, not living and not dead, but informational. Information is a strange category. It has no weight, no smell, no texture, and yet everything depends on it. Information tells electrons how to align on a chip, it tells amino acids how to fold into proteins, it tells stars when to burn and when to collapse. Perhaps, then, we are not speaking about viruses as attackers or packets as empty carriers, but as members of this universal family of messages, fragments in the endless conversation through which the universe speaks to itself. Consider how this realization reorients our perception of disease. Traditionally, infection is a war. Bodies resist. Doctors speak of battles. Media headlines portray microscopic struggles as looming wars. But what if, beneath the metaphor of violence, there is another metaphor more calm and more precise: communication? When you contract a virus, it may be better to say your body is reading a foreign file. Sometimes the file is safe enough, teaching new tricks to the immune system, granting subtle resistances for the future. Other times, the file is corrupted, disruptive, a malicious pattern that overwhelms the normal operating system. Framing it in language of communication rather than war creates a new tranquility, an acceptance that life is filled with messages, both expected and unexpected. Some we welcome, some we delete, some we archive for reference. The body is not always under siege, sometimes it is simply busy reading, sorting, parsing, deciding what to keep and what to discard. The staggering mystery arises when we consider how similar this is to the way the internet learns and grows. Every second, devices send information across cables and wireless channels, not all of it safe, not all of it trusted. Firewalls reject some, machines quarantine others, users rewrite scripts, filters clean streams. Through this process, the network survives. Through a parallel process, the human species has survived viruses for millions of years, each message teaching resilience, each outbreak leaving traces of resistance in the code of our DNA. Somewhere between digital and biological security, a single principle seems to echo: survival is not about eliminating all foreign messages, but about negotiating with them, adapting to them, rewriting yourself in response. The more one gazes into this analogy, the deeper it leads, pulling thought into an ocean of patterns. Consider the role of mutation. On a network, a packet may be corrupted by noise, altered by accident, or reshaped deliberately. Sometimes the mutation makes the packet unreadable, discarded immediately. Sometimes, however, the mutation creates new opportunities, revealing vulnerabilities or possibilities in the receiving system. In viruses, mutation is the very fuel of persistence. Small errors in copying create endless diversity, giving rise to variants strong enough to bypass immune firewalls. In both domains, mutation is an engine of change, unpredictable yet inevitable, always reshaping the landscape. One begins to sense that mutation is not a flaw, but a vital syntax of communication across realities. As you listen, let the thought shimmer quietly: could it be that life itself is just a vast network of messages, where stability is rare, where constant flux is the rhythm, where every being is both sender and receiver? In this sense, viruses are not aberrations but essential participants, carriers that remind every organism that it is connected to larger flows of information. If every living cell and every computer is a node, then viruses and packets alike are the messengers traveling between them, ensuring that connection never ceases. Without them, growth slows, Evolution stalls, novelty fades. Dangerous though they may be, they also supply variation, reminding systems that stasis is impossible, that to live means to be in communication with all that surrounds you. The metaphor extends even further, into the profound question of consciousness. Our thoughts arrive as pulses, signals coursing along neurons. What are they if not packets of meaning? Each word you hear in this narration is simply an organized packet of sound entering your mind, encoding instructions that your brain unpacks and interprets. Just as a virus needs a cell, and just as a packet needs a server, so too do words need a mind to become alive. Without a receiver, there is no message. Without a host, there is no virus. Without a network, there is no packet. Existence itself begins to resemble an immense symphony of dependencies, where everything must flow into something else to be real. Envision an alternate history where both viruses and data packets are openly recognized as kin, as twin phenomena echoing one another across dimensions of life and technology. Instead of fearing one and taking the other for granted, perhaps we would see both as crucial instructors, teaching us about the fundamental patterns of transmission, security, and resilience. In that serene vision, a sickness is not simply a battle wound but a message from the universe. A wrong file on your computer is not only a disruption but a reminder of the fragility of systems. Both remind you that perfection is an illusion, that error and infection are part of flow, that connection always includes risk, and yet it is this unpredictable energy that makes growth possible. Let your breath match the rhythm of these thoughts as they lengthen and stretch into silence. The world is filled with invisible carriers, unseen messengers drifting from one body to another. Viruses tease open the concept of identity, reminding us that we are not closed systems. Data packets remind us too, for they show how no device is alone, no server is hermetically sealed. To live is to be permeable, to constantly receive and transmit, whether through breath, thought, or digital fiber. There is no life without openness to the greater exchange. And in that realization comes, strangely, peace. For if everything is a message, then even what appears as harm is part of the same dialogue, a contribution to the infinite archive of interactions that make reality sing. When we start to think about viruses as data packets, another layer of imagery begins to emerge, one that brings us into the unsettling but fascinating territory of intruders, saboteurs, and unseen manipulators who write scripts and release them into vast networks. If the body is a system of living nodes and the immune system is its firewall, then the virus becomes a line of code injected into that system, and suddenly a shadowy question flickers through the metaphor like a candle in the darkness: who, or what, could we call the hackers of the biological realm? In the familiar context of computer networks, hackers are those who deliberately search for vulnerabilities, who slip past defenses and force systems to run commands they were never intended to run. But in the biological domain, the so-called hackers are everywhere, and they may not even be conscious in the way we normally imagine. Mutation itself is one such hacker, a blind, mechanical tinkerer that reshuffles the code of a virus generation after generation, ensuring that some of these reassembled fragments of information will find new doorways into hosts. Evolution, in its patient, untiring slow motion, is another hacker, continuously probing, endlessly testing, always uncovering pathways. And sometimes, of course, there are human beings themselves, deliberately sculpting genetic material, adjusting sequences with intent, crafting new instructions for cells or systems to obey. When you allow this perspective to settle into your mind, you begin to realize that hacking is not necessarily an act of malice but an act of alteration. The hacker, whether natural or artificial, is a figure that introduces novelty into the flow of information. Sometimes novelty disrupts, sometimes novelty destroys, but sometimes novelty innovates. In computer science, many pathways now considered standard procedures were once clever hacks, shortcuts discovered by those willing to break the rules. In biology, the virus is sown out of countless natural hacks across the timeline of evolution. Each attempt at infection is a test, an exploration, a probing of the boundaries of what can be done with the machinery of the cell. Every successful infection, grim as it may feel when we face it personally, is at the same time proof of the richness of adaptive strategies that nature unveils. So the hacker's intrusion brings both danger and creativity, the two sides bound together, inseparable. In a world of packets, networks, codes, and defenses, there is one other fact that speaks louder the more we listen: there is no such thing as a perfect system. Every firewall has holes, every operating system has unpatched vulnerabilities, every immune system has weaknesses waiting to be exploited. Viruses exploit them in biology. Data packets carrying malicious code exploit them in machines. Hackers, in their countless forms, are reminders of this irreducible imperfection. And this realization, curiously enough, creates its own calm. For if imperfection is woven into the network, then exposure is not a failure but a condition of being alive. To communicate is to risk corruption. To receive a signal is also to invite error. Existence itself requires this balance, this ever-present tension between the order of systems and the chaos of unexpected messages. Think of the time before modern computing, when people first confronted viruses in the biological sense without the language of networks. Illness felt like possession, a haunting, an invasion of spirits. In truth, these metaphors were not so far from the mark, because viruses are indeed messages that arrive from outside, carrying an alien script. They hack into cells because that is all they know how to do. Fast forward to the age of digital technology, and people face a parallel fear: malware, ransomware, hidden code that infiltrates our machines and demands obedience to an alien agenda. Again, the metaphors of fear appear: infection, corruption, poisoning. This symmetry between biology and technology is profound. Both are vulnerable. Both are targeted by intrusions. Both fight back with detection systems, firewalls, antibodies, quarantine spaces, backup strategies. Both reveal that to interact with a larger world is to make yourself permeable, and permeability is vulnerability, yet it is also the precondition of growth, connection, and life itself. Allow your mind to wander through the image of the body as a vast operating system. The organs are modules, running specialized programs. The heart is a scheduler, pulsing with clock-like precision, ensuring that resources flow in synchrony. The liver is both a filter and a processor, cleaning inputs, balancing instructions, endlessly translating chemical data into usable forms. The immune system is not just a firewall but a constantly updating, self-learning security suite, creating signatures of known invaders, storing them for reference, deploying countermeasures on the fly. This system never rests because the flow of incoming packets never ceases. Every breath you take introduces not only oxygen but unknown traces, particulates, fragments of code drifting through the invisible ocean of air. Every meal you eat is not simply nutrition but also a stream of chemical signals that must be decoded. Every touch with the world introduces novelty, and within that novelty may lie new scripts that will be read, tested, resisted. The body, in all of its elegance, is an operating system open to constant input, resilient enough to keep running despite errors, flexible enough to update as new challenges arise. From this view, the virus is not a stranger but a particularly aggressive network intrusion. It knows the protocols of the cell and exploits them carefully. Its proteins are like stolen access credentials that bypass the gatekeepers. Its timing is precise, hitting vulnerabilities at the right moment. Once inside, it does not smash the system to pieces but rather reroutes the instructions, convincing the internal processors to repeat its script over and over until the system's resources are drained. This is the same logic that unfolds when a malicious data packet finds its way into a digital network. The packet looks ordinary enough on the surface, disguised as any other message. But its payload is designed to redirect, to replicate, to choke the system with endless demand, until regular priorities collapse under the strain. Whether in biology or in technology, the pattern is the same: intrusion, deception, replication, disruption. And yet the symmetry is not only alarming but also strangely beautiful. Because within that symmetry lies understanding, and within understanding lies calm. To recognize that these intrusions follow patterns, that they slot into larger architectures of information, is to see that we are not helpless victims but participants in a larger design. Firewalls can learn. Antibodies can adapt. Systems can patch themselves. The struggle between packet and firewall, between virus and immune system, is not endless war but recursive teaching. Each invasion teaches the system. Each failure is archived as memory. Each defense that emerges carries forward into the next generation. Systems, both biological and digital, are alive precisely because they are not static. They survive because they are not rigid. Hacking, then, is not only intrusion but also initiation, not only theft but also transmission of lessons about resilience and awareness. Breathe deeply into this realization. Imagine the immune system updating itself like antivirus software. Imagine new white blood cells as pattern recognizers freshly trained to spot new types of headers on viral packets. Imagine your DNA as a changelog, slowly recording what your ancestors endured, patching itself with every epoch, leaving you with a body that already knows how to face countless intrusions. The image is soothing because it suggests continuity, inheritance, and adaptation. You are not alone in facing hackers, because your very structure is the autobiography of survival, filled with the memory of sentinels who recognized the same tricks long before you existed. Just as networks evolve better protocols to resist intrusions, so too do living systems evolve stronger alignments to resist their hackers. In a world where nothing can be perfectly secure, resilience matters more than immunity, adaptability more than resistance, and the ability to update is the most precious skill of all. Now pause and let the idea drift further. Hackers in biology are not always external. Sometimes hacking occurs from within. Cellular processes themselves can slip, an error of replication here, a duplication there, a silent rewrite of the code that produces something unexpected. Cancer, in one sense, can be considered an internal hack, where the body writes code that rewires its own programs, redirecting growth and ignoring the firewall of normal regulatory signals. In digital systems, similar internal hacks occur when glitches produce endless loops, or when corrupted files spread within the system without external interference. The hacker, then, is not an enemy outside. The hacker is a possibility within the system itself, a reminder that imperfection exists even at the heart of the operating logic. What follows from this perspective is an understanding that hacking is intrinsic to the process of evolution, to the process of adaptation, to the very unfolding of life itself. Without hackers, systems would remain closed, inflexible, static, and ultimately fragile. With hackers, systems are tested endlessly, forced to grow new defenses, forced to innovate, forced to rewrite. Viruses, data packets, mutations, errors, all of them trouble us, but all of them also keep the story of life moving forward. To accept the hacker as part of the design is to release fear and replace it with cautious wonder. For this is how novelty happens, this is how change breaks through, and this is how systems, even weary ones, find their way toward resilience. If the body is to be understood as an operating system, then we must begin to imagine its architecture not only in fragments, but as an entire symphony of functions working together, running in parallel with breathtaking precision. The heart, the liver, the brain, and the lungs, countless cells and tissues, act as modules that communicate without pause. They are not isolated. They are threads in a great web, lines of code in a program too vast for any single observer to comprehend completely. When a virus arrives, or when a data packet slips across a digital wire, it must locate and interact with this network architecture. It must knock at doors, it must use credentials, it must persuade the machinery to let it in. Sometimes it is denied, sometimes it is destroyed on contact, sometimes it is permitted to pass. This process is not random chaos, it is structured, as if the system itself has been designed from the beginning to function as both a gatekeeper and a host, a balance between letting information flow freely and protecting against intrusion. Think of the way a computer must multitask, running applications, updating protocols, managing inputs, balancing resources under pressure. The body does the same, but with infinitely greater complexity. At every second, millions of biochemical signals ripple through you, carrying instructions, triggering responses, organizing defenses. This hidden orchestration is the very definition of an operating system, a vast middleware that allows inputs to be turned into outputs, while shielding the fragile processes running in the background from complete collapse. To live, in this sense, is to maintain a balance between openness and control. Too much control, and the system becomes rigid, suffocating under its own inflexibility. Too much openness, and the system dissolves under the flood of incoming packets it cannot process. Within this constant balancing act, the immune system rises like an unsleeping guardian, both sentinel and teacher. The immune system is often described as an army, as a set of soldiers standing guard. But inside the metaphor of networks and operating systems, we might see it differently. It is not only a defense, but also a filter, a continuously updating firewall that grows more sophisticated with each encounter. Antibodies are not soldiers, they are pattern recognizers, strings of code written in protein form, able to spot suspect headers on viral packets and flag them for removal. White blood cells are not merely fighters, they are analysts, parsing the data inside those packets, learning from it, archiving it. Memory cells are nothing less than persistent storage, a hard drive of the immune system, reminding the body how to recognize familiar attackers so the threat does not need to be decoded from zero each time. In this way, the living body can be seen not only as a machine but as a constantly evolving machine, a security system rewriting its own protocols after every encounter, updating its libraries endlessly in order to keep pace with the changing tide of viral information. Take the example of a vaccine. In the language of our metaphor, a vaccine is not ammunition but an intentional software update. It is a patch. It introduces the system to a simulated packet that behaves like the real thing but without destructive payloads. The firewall scans it, learns it, and stores it away. The next time the true malicious packet arrives, the firewall already has the rules written, the filters set, the antibodies waiting like precise lines of code capable of shutting down the intrusion before it gains control. This is not unlike releasing a security update for a computer, pushing patches into devices across the network so that when a newly discovered exploit makes its way across the system, those who have updated are safe, while those who run outdated versions of the code are more easily breached. The metaphor clicks into place so easily because in both biology and technology, the principles are mirror images of one another. As you let this imagery unfold in your imagination, it begins to feel almost obvious that systems as different as our bodies and our machines are obeying the same fundamental logic. Both are engaged in the endless task of running code, keeping processes alive, defending against intrusion, and constantly updating to meet new demands. They are shaped by the streams of information that move across them, tested by the unexpected, refined by exposure. The viruses and data packets that travel through these systems are not external at all, they are the essential lifeblood of communication, carriers of novelty, reminders that connection is also exposure, and exposure is also transformation. Pause and imagine a single cell as a tiny workstation. Around it is the plasma membrane, the door, the access gate, through which signals and packets must pass. On that membrane are receptors, passwords and locks, opening only for the keys they recognize. A virus approaches with a forged key crafted by mutation and honed by chance. The receptor clicks open, and the viral packet enters. Inside, it unpacks itself, its envelope dissolving like the outer shell of a data packet stripped away by protocols. What is left is the core, the code, short yet profoundly precise. This code finds its way to ribosomes, which act as processors, reading the script one line at a time, assembling proteins the way a digital processor runs instructions in sequence. The cell does not know it has been hacked, it only knows it has instructions to execute. And so the packet S code runs, producing not the original programs of the cell but endless copies of the invader S tools, filling memory, draining energy, redirecting processes until the system is under strain. And yet, zoom outward, and you see this exact image already exists in the digital counterpart. A malicious script arrives in an email disguised as harmless. The system loads it. The code begins to run. Files replicate, backdoors open, processes slow, priorities are hijacked. The machine, once stable, begins to serve another master. Antivirus software then intervenes, if it can, recognizing patterns, scanning signatures, blocking ports, scrubbing the system clean of files it never should have run. Sometimes it succeeds, sometimes it fails, but the pattern is so eerily parallel that it causes you to wonder whether both domains, biology and technology, are not separate inventions, but rehearsals of the same play, experiments based on the same pattern that reality keeps testing over and over again. And now, let us think of the operating system itself not as a battlefield, but as a garden of signals, endlessly maintained, endlessly self-pruning, endlessly reshaping itself to remain functional under pressure. A garden must allow new seeds to take root, yet it must also control the weeds that seek to dominate. A body does the same, allowing nourishment, welcoming oxygen, accepting proteins, while at the same time resisting microbes, filtering toxins, identifying hostile viruses. Technology does it too. Networks must accept genuine packets, welcome useful data and legitimate traffic, while rejecting malicious streams before they cause collapse. The endless negotiation between openness and closure is the very definition of what it means to remain alive, to remain functional. The metaphor deepens. It is not a war, but a dance. A graceful balancing act between what must be received and what must be rejected, between trust and suspicion, between nourishment and attack. If you imagine your immune system as a firewall, remember too that firewalls are not static. They are dynamic. They learn and adapt. They rely on stored experiences, on reference tables of known threats, but they also possess heuristics, generalized strategies that allow them to spot unfamiliar but suspicious behavior. When foreign proteins behave strangely, the immune system intervenes, much like a firewall stopping traffic that looks suspicious even if it has never been catalogued before. Memory is combined with pattern recognition, past experience with present intuition. The result is resilience. Resilience is not the same as invulnerability. It is the willingness to take blows, to suffer intrusion, and still recover, stronger and wiser than before. Every scar on DNA, every archive of antibodies, every line of firewall code, is a reminder that the system has faced the world and endured. This quiet strength is what makes survival possible. Within this frame, it becomes clear that the firewall is not a wall at all. It is a translator. It is the bridge where information is sorted into meaningful and meaningless, harmful and useful. Without it, there would be chaos. With it, there is order, but it is a fragile order, contingent, constantly renewed and reinforced only through repeated encounters. Life teaches the immune system. Networks teach their firewalls. Without threats, the defenses would atrophy. Without challenges, updates would never come. Without exposure, resilience would never grow. This may explain, at a deeper level, why viruses remain part of life, why we cannot eliminate them entirely, why the flow of foreign code is eternal. Packets must travel the network, information must exchange, novelty must enter, and so the system must remain open. This openness guarantees vulnerability, but it also guarantees growth. A perfectly sealed system is no system at all, it starves in isolation. To live is to be patched, not once, not occasionally, but constantly, endlessly, with every breath, every beat, every contact with the world. You are not running a finished program. You are running a program that updates itself in real time, continuously. The body is not a fortress. It is an evolving operating system, porous, flexible, open, learning through the endless arrival of viral packets and informational flows. Now imagine drifting into this awareness as you sleep. Each inhalation of breath is an incoming packet. Each exhalation is an outgoing confirmation. Your body filters and decodes them gently, half aware, half unconscious, just as networks run silently in the background day and night. They do not stop. They do not rest. They are steady currents, simple proof that being alive is being connected. There are threats, yes, but there are also gifts. There are errors, yes, but there are also opportunities. The firewall at work is not only protecting you but shaping you, guiding you toward resilience, ensuring that you remain both open and safe, both vulnerable and strong, both alive to the flows and firm against their harms. And it is in this endless equilibrium, fragile, dynamic, and perpetually renewed, that life continues, that the systems of biology and technology both survive. When we think about how viruses spread, and when we cast them in the role of data packets moving across a great living network, the metaphor deepens, stretching into a new clarity. A virus is not only a fragment of code. It is also a traveler. It is an uninvited passenger, slipping across borders, leaping between nodes, multiplying as it goes, determined not by its own will but by the simplicity of the instructions it carries. There is no malice in it, no conscious scheme, only transmission. But the transmission itself is relentless, unstoppable, like packets rushing through cables, broadcast invisibly through the atmosphere, flooding bandwidth until the network strains. To understand the spread of viruses, either biological or digital, is to understand the inevitability of connection. No system exists in isolation. Every system is porous. Information, messages, signals, strangers, floods, they all arrive because the system breathes. It breathes data, it breathes code, it breathes novelty, and in every intake there is risk. Picture the path of a biological virus in slow motion. A cough carries droplets into the air, droplets that hang, shimmering, filled with countless packets of genetic script. Those droplets linger until they enter another breathing body, until they settle on surfaces waiting for fingers and hands to carry them forward. Invisible but ceaseless, the packets fly from one host to another like whispers carried on the wind. Their life is not in the particle, but in the transmission. Just so, in networks, malicious data does not sit idle, it propels itself forward, copied from server to server, forwarded across Reuters, piggybacking in files and messages unnoticed by distracted users. The virus spreads not because it seeks to, but because spreading is inscribed in its code. To spread is to fulfill its only instruction. The similarity between these two forms of infection is so striking that one suddenly feels the line between infection of the body and infection of the machine soften, blur, dissolve. The image of replication is its own kind of hypnotic rhythm. Think of cells, millions of them, silently working each second. One virus enters. It is so small, so inanimate, yet once inside the system, it multiplies. In an hour, one becomes hundreds. In a day, hundreds become millions. Each copy is itself a new packet ready to be delivered to another host, another node in the swelling web. The process is exponential, extravagant, excessive, unconcerned with limitation. The code is simple: replicate, transmit, continue. Exactly the same principle appears in the digital swarm. One infected file is copied, attached, and passed along. In networks, one machine infected becomes two, two become four, and soon thousands of machines in distant corners of the globe are repeating the same stolen code, flooding the network with cloned instructions. It is this principle of replication, blind, automatic, rapid, that makes both biological viruses and digital viruses so powerful, so difficult to contain, so persistent inside the flows of life and technology. Yet amidst this image of ceaseless replication and flooding transmission, there rises another awareness: networks, whether made of cells or cables, are resilient because they are not passive. They are not helpless victims of the storm. As viruses spread, so do responses. As malicious packets surge across networks, so do countermeasures, blocks, quarantines, filters, shields. Every infection triggers a counter-infection, every spread opens a closing, every flow awakens another current. And in this balanced tension we find the dance. The beauty of networks is that they are active, alive, learning as they resist. Every immune system that survives an infection is stronger for it, storing signatures, waiting for the next attempt. Every digital network that endures a major worm inspires new patches, improved protocols, tighter filters. The battle is never final, never complete, but it is in the repetition of spreading and defending, flooding and blocking, that systems find renewal. When you step back and imagine this vastness, the metaphor stretches across the planet itself. Humanity is a network, linked by proximity, by touch, by shared air. Infection spreads along these links, just as data spreads along fiber and frequency. Cities glow like nodes in the dark, airports like Reuters, people like packets, carrying fragments of code wherever they travel. This planetary network is porous, restless, alive, and viruses ride upon it as easily as information rides upon digital cables. The power of connectivity is double-edged. It brings communication and knowledge, but it also accelerates transmission of dangerous code. The same aircraft that delivers medicine across continents delivers infection across borders. The same cable that delivers wisdom and connection carries malware side by side. Openness makes us strong, openness makes us vulnerable. The paradox cannot be broken, only lived. Rest with that paradox for a moment. Feel its texture. To connect is to risk infection. To disconnect is to starve. The internet without data would be nothing but silent wires. A body sealed forever from novelty would wither in sterility. Openness and risk arrive together, always. This is why spreading viruses can be painful, but it is also why spreading information is essential. In some hidden way, both exist on the same spectrum, signals moving, shifting, testing boundaries. We cannot accept one without touching the other. Consider also the concept of latency, both in digital and biological domains. A packet can be delayed in transmission, stored in buffers, waiting before it passes along its path. A virus can sleep in silence inside a body, remaining unnoticed, invisible, inactive, until circumstances awaken it. Latency is a form of waiting, a pause in the narrative of infection. Yet within latency is danger and also mystery. A delayed packet may arrive long after its origin has been forgotten. A dormant virus may awaken years later, carrying with it echoes of an encounter far in the past. In both systems, latency reminds us that messages are never only about the present, they are also about the past and the obligations of memory. The network remembers. The body remembers. Messages can remain hidden, silent, waiting, until one day they suddenly arrive. And as viruses spread, systems multiply their defenses, but so too do people spread meaning around them. Each infection yields stories. Networks share warnings, patch notes, advisories. Bodies share immunity, antibodies passed from mother to child, collective resistance cultivated over generations. Just as an infected machine becomes a warning to its user, an infected community becomes a lesson to its descendants. The chain of transmission is thus not only about the viral packet itself, but about wisdom, about adaptation, about long echoes of memory. Information of harm becomes information of strength. Messages of destruction become messages of resilience. That is the strange alchemy of communication. Even what arrives uninvited may, in its cycle of spread and response, leave behind a gift. Let your breath synchronize with this thought: the spread of viruses is not chaos. It is part of a structure, a rhythm, a set of interactions that reveal the way all systems live. Systems live because they exchange, because they risk, because they adapt. No firewall closes perfectly, no immune system halts every invader. Instead, both adjust, both learn, both rewrite themselves again and again. The endless replication of viruses may seem unstoppable, but it is matched by the endless renewal of defenses, the ongoing updates of systems that refuse to collapse. In this refusal lies the quiet beauty of survival. It is not about purity or perfection, but about adjustment, about flexibility, about staying open even in the face of risk. Imagine drifting in sleep with this vision: the world itself is a web of nodes, every form of life breathing packets into the air, sending signals outward. Viruses are among them, strange travelers without intention, repeating the same lines of code. Data packets flow beside them, human-made, pulsing in machines and towers. Both cross vast distances, both fill the network with ceaseless presence. And every moment, firewalls and immune defenses hum softly, unobserved yet alert, filtering, blocking, adapting. It is an endless cycle: spread and resist, flood and drain, enter and block. Yet within the cycle there is calm, because the cycle itself sustains the system. The spread of viruses ensures that defenses remain alive. The spread of defenses ensures that viruses evolve. Both need each other. Both continue. Life itself is not the absence of infection. Life is the art of enduring within its presence. And so, as your body rests and breathes, remember that you are part of this great cycle. Each cell is a node, each breath an exchange, each defense a firewall rewriting its code for tomorrow. Packets flow through you and around you, endlessly. They carry danger, yes. But they also carry connection, novelty, transformation. To live inside a network is to live inside their flow, and to live inside their flow is to grow. In this understanding, fear softens, worry dissolves, and all that remains is the gentle knowledge that existence is an exchange, spreading, adapting, balancing, renewing, forever. When we imagine the spread of viruses as messages carried from body to body, traveling the invisible highways of air, liquids, and contact, we cannot avoid the thought of how systems attempt to strengthen themselves against the constant flood of signals. In digital networks, when a new form of malicious code is discovered, developers rush to create patches, to update their users with software designed not to erase the existence of danger, but to transform the system into something harder to breach. In biology, the equivalent emerges as the practice of vaccination, though in truth, vaccination is only one manifestation of a much broader and older principle: the idea that living systems must continually receive updates, must continually refresh their definitions of threat and safety, must continually learn how to recognize unfamiliar code before it can overwhelm the processor. Without updates, the system becomes obsolete. Without fresh knowledge, the defenses grow stagnant. To exist inside a networked world of machines or of organisms is to accept the inevitability of version changes, of constant reprogramming, of new lines of defensive code interwoven into the fabric of the operating system itself. Think of the way an antivirus program downloads new definitions each day. It is not that the software was useless without them, but that the field of threats is always shifting. Malware designers alter headers, disguise payloads, change patterns, mutate their packets into forms that no pre-existing rule will recognize. This constant shifting is precisely what viruses in biology accomplish through mutation. Each replication carries the possibility of change, and some changes will disguise the intruder well enough to sneak past yesterday's defenses. A firewall frozen in time would quickly fail. So too would an immune system frozen in time. And so life answers with memory, with flexibility, with its own updates, white blood cells changing tactics, immune systems remembering signatures, communities creating vaccines that act like software patches distributed on a mass scale. A vaccine is not only protection, it is an intentional download of defensive language into the operating system of the body, a packet of instructions that says, here is what to look for, here is what to block, here is what to remember. The metaphor deepens when you consider the context of community. An update on one computer does not protect another unless the update is installed across the network. Similarly, immunity in one body helps that body survive, but it is collective immunity that helps the network of humanity slow the spread of malicious packets. A firewall on one device may keep that machine safe, but if the surrounding network is unprotected, the cables will still hum with harmful code, crashing into walls, bouncing against defenses, exhausting resources. The biological metaphor is even clearer. When enough hosts are patched, the pathways for viral packets shrink, the replication slows, and what once spread like wildfire now finds only walls. Herd immunity is not only a biological principle, it is a network principle, the natural result of distributing security updates across a wide enough field to slow down replication. Once more, we do not find analogy here but parallel. The same strategies are whispered through biology and technology, as if systems across every domain learn from the same invisible source. Imagine settling into sleep while your mind drifts through this vision of constant updates. Your body is an operating system that is never static. While you dream, immune cells drift quietly like silent administrators, running background processes, checking signatures against stored patterns, comparing packets against the rules written long ago by previous infections and vaccines. Some processes are interrupted and removed before you ever feel their presence. Others might cause mild disturbances, an error message, a slowed processor, a fever as the system alerts you that it is beginning to patch itself. What feels like discomfort is often the sign of healing, the visible trace of the immune system introducing new rules, tuning itself to resist future intrusions. In the same way, when your machine updates its system, it slows, halts, reboots. These pauses cause inconvenience, but their purpose is continuity. They ensure tomorrow's challenges can be met. The discomfort is temporary, the advantage is permanent. When you see the immune system not as an army of war but as a constantly updating software system, the vision of life changes. It becomes less about invulnerability and more about adaptability. Vulnerability is not a defect but a condition of networking. No system can remain permanently immune because no system can remain permanently current unless it updates. Thus, the immune system is never finished. It is a project always in progress, a work under continuous construction, forever patching against new vulnerabilities. The miracle is not in its perfection but in its resilience, not in its endless walls but in its endless willingness to learn new lessons and rewrite itself. The elegance of this truth is calming because it allows us to release the expectation of flawless defense. It is enough to know that the system is always at work, always scanning, always ready to learn. Security is not absolute, security is adaptive. Now consider the possibility of personalized updates. In digital life, antivirus engines are becoming smarter, using artificial intelligence to analyze unfamiliar packets not by reference to known signatures but by the way the packet behaves. They can detect anomalies, spot irregularities, build a defense in real time without waiting for external patches. In biology, whispers of this future exist already. With technologies like mRNA vaccines, we are not only learning to provide memory against known viral signatures, but we are beginning to imagine a world where updates could be written on demand, where customized protective instruction could be generated almost overnight for a newly arisen virus. Nature has relied for eons on the slow process of immune learning, but humanity as a technological organism is beginning to give itself the power to accelerate the distribution of patches, to synchronize biological systems with the same rapidity as digital ones. The metaphor is not straining, it is merging. Biology is beginning to receive updates with the ease of machines, and machines are learning to update themselves with the adaptability of living hosts. The thought expands further into the realm of preventive defense. Imagine firewalls that anticipate attacks before they happen, systems that learn not only from attacks they have seen but also from patterns they predict. Imagine immune systems enhanced in similar ways, capable of simulating viral packets before they appear in the world, building memory against them in advance. Already, some scientists attempt to create universal vaccines, predictive updates designed not for one variant but for entire classes of viruses, so that any packet arriving from that family of intruders would already be recognizable. In the metaphor of operating systems, this is like installing a meta-firewall, a deep heuristic shield that filters not only known exploits but entire categories of procedural algorithms. If achieved, both in biological health and technological security, it would represent a profound leap, anticipation rather than reaction, foresight rather than repetition. It would be as though the system has learned to predict not only threats that exist but threats that could exist, sketching potential packets before they arrive. What makes these analogies soothing to rest within is their familiarity. You live inside systems that update daily, without your constant intervention. Your devices update themselves while you sleep. Your body updates itself while you sleep. Even now, as your consciousness relaxes, as your breath falls into rhythm, countless background processes are running within you, patching, repairing, reinforcing. These updates happen beneath awareness, silently, unobserved. But they are ceaseless. They remind us that strength does not come from watching every possible channel, but from trust in the countless invisible processes that have kept life moving for billions of years. Trust in the immune system that hums like an entire orchestra without a visible conductor. Trust in the digital protocols humming across the planet, repairing themselves in endless cycles. To lie in bed and release yourself to sleep is to acknowledge that defense continues in your absence, that updates install themselves beyond your control, that you are not required to guard the firewall at every second. The system is alive. The system remembers. The system will carry on. Think too of how updates are written into human memory itself. Each generation experiences viruses, fights them, cultivates resistance, and writes those lessons into DNA. Over time, fragments of viral code themselves become embedded inside genomes, no longer invaders but permanent residents, rewritten into the cellular operating system until they serve new purposes. What was once intrusion becomes function. Some viral sequences have been kept and co-opted, forming essential roles in processes like pregnancy, immunity, or gene regulation. The system has not only patched itself against those viruses but has incorporated their code, turning adversaries into partners. This is as though computers learned not only how to block malware but how to take useful parts of the malicious scripts and integrate them into their own operating system, forever transforming an earlier intrusion into a new tool. The metaphor reveals again the elegance of adaptability. Nothing is wasted, not even infection. Every packet carries potential, and though danger often outweighs benefit, sometimes information left behind becomes part of the system's own evolution. So the story of updates is a story of assimilation as much as resistance. Systems refine themselves not only by blocking, but by absorbing, by taking what was foreign and making it familiar. This is how cultures grow too, through contact, through messages received, through foreign codes that become native after time and translation. In this way, vaccination, patching, updating, these are not foreign practices but natural reflections of what systems, whether biological, technological, or cultural, have always done. They take what arrives, resist what they must resist, accept what they can accept, and use the rest to build themselves into something stronger than before. As the thought settles, the image of updates takes on a soothing cadence. Each day, you receive countless packets of information, both benign and dangerous. Your body filters them, accepts some, blocks others, integrates a few. Each day, your machines download new lines of code that make them safer than before. Each day, your mind, too, updates itself, learning from the experiences that pass through you, integrating lessons into your memory so tomorrow you may meet the world with greater resilience. Updates are not interruptions. They are the rhythm of being. They are how life continues. To accept updates is to accept participation in the broader network, to accept that to live is never to remain still, to accept that safety is woven not out of walls but out of perpetual motion, perpetual rewriting, perpetual change. And it is in that perpetual change that security, resilience, and peace are found. As you drift deeper into thought, you may recognize that this metaphor shows something profound. A system that refuses updates is not simply more vulnerable, it is already dying. A body that refuses novelty, that locks itself completely away, cannot sustain itself. A mind that refuses experience, that walls itself off from new ideas, stagnates. Life is not sustained by isolation but by cautious openness, by selective permeability, by welcoming enough of the stream to grow without being drowned. This balance is difficult, but it is beautiful. It ensures that the network flows, that organisms evolve, that cultures shift, that information grows richer. Updates remind us that to change is not to lose stability, but to maintain it. And so, the immune system updates itself, vaccines accelerate those updates, firewalls update themselves, networks accelerate those updates. Renewal is continuous. Renewal is life. Drift calmly now into this recognition: you are not a finished program. You are an unfolding one. Every breath is an update. Every encounter is an update. Every memory is an update. You are rewritten day by day, moment by moment, line by line of living code, not less stable because of change, but more stable precisely because of it. Updates weave resilience into your being. Updates weave wisdom into your defenses. Updates are the way life ensures you do not remain yesterday's version forever, but grow into what tomorrow requires. In this awareness, even viruses cease to be wholly foreign. They are reminders that updates are still required, that flexibility is still necessary, that perfection is not an option but resilience always is. Sleep within that rhythm. There will always be packets traveling. There will always be updates arriving. There will always be change. Let it come. The system knows what to do. And so, life continues. The thought of updates, of resilience, of systems that learn through contact, leads naturally into another horizon. If life has always been about the interplay of information, if viruses are not only invaders but also messengers, then what might happen if humanity learns to intercept, redirect, or even rewrite these messages deliberately? For ages, we have regarded viruses as accidents of nature, scripts unleashed without intention, forever rewriting the codes of our cells against our will. But in recent years, the metaphor has shifted. Scientists now resemble programmers as often as anatomists. They enter the hidden architectures of genetic code, searching for vulnerabilities and possibilities, editing them carefully the way a developer refines faulty or outdated lines of instruction. To imagine viruses as data packets now becomes more than a metaphor, it becomes a map of our own future, a blueprint of what we may learn to do with unprecedented precision. Once we see viruses as carriers of information, the next step is to acknowledge that we ourselves may someday design such carriers, not to harm but to heal, not to undermine but to enhance, not to break the system but to strengthen it. Consider what a virus really is: a small package that delivers code into a cell. It cannot survive alone, but placed inside a living system, it unlocks new functions by convincing the machinery to translate its instructions. Today, laboratories already exploit this principle in gene therapy, hijacking the viral mechanism for benevolent purpose. Instead of instructing a cell to replicate endlessly, the engineered packet carries instructions to correct a flaw, to replace defective code, to install a missing protein that the system requires. The same principle that once caused suffering now becomes a pathway to healing. This is the equivalent of a developer writing a patch, embedding it in a packet, releasing it into the system not by email or network update, but by injection, so that the operating system of the body reads the new code and begins to repair itself from the inside. What is startling is not that this can be done, but that it works because of the same universal logic: all systems believe in packets. If a message arrives in the proper format, the system will read it. Whether in silicon or in carbon, the architecture is the same. Once this realization dawns, the imagination drifts further outward. If every life form is already a node in a hidden network of messages, then it is possible to see a future where we use this network deliberately, where engineered packets move not only within single bodies but across entire communities, updating not merely individuals but whole ecosystems. Just as software patches can be sent across a global internet so that millions of devices update overnight, so too might biological patches be distributed across nations to update immune systems, to correct inherited weaknesses, to strengthen resistances against threats old and new. In this light, the metaphor ceases to be speculative and becomes prophetic, a hint that humanity's mastery of information will soon extend seamlessly between the biological and the technological domains until the boundaries that once divided them no longer matter. The thought can appear breathtaking, but it may also appear unsettling. For if we can rewrite the code of viruses to heal, then we can also rewrite them to harm. What today seems like weaponized malware in the digital world could tomorrow become engineered pathogens in the biological one, tailored lines of instruction built not by blind mutation but by deliberate hands. The metaphor reminds us that every tool is double-edged, that every packet capable of repair is also capable of disruption depending on intent. Just as firewalls must grow stronger as hackers grow more sophisticated, so too must systems of global health become as vigilant as systems of cybersecurity. For in the same instinct that drives us to cure, there dwells also the possibility of corruption. The packet, after all, is neutral. It is a carrier. What matters is the code it holds. And yet, imagine this not as a threat but as an awakening of potential. Envision a world where viruses are no longer feared, but farmed, packets we write ourselves, like custom programs, uploaded into the operating systems of living bodies with the precision of developers adjusting code. A child born with a weakness in metabolism could receive a packet carrying new genes to rebalance the system. An elderly patient facing the slow decline of tissue could receive packets that instruct cells to rejuvenate, to restore, to extend function beyond what natural processes allow. Communities facing pandemics could be patched with dispatches of code written overnight and distributed like software updates, turning vulnerability into resilience not in decades but in days. The language of fear dissolves, replaced by the language of engineering. Viruses become not enemies but tools, not malicious hackers but couriers under our direction, driven not by blind chance but by human design. Reflect slowly, this transformation mirrors what has already happened in digital networks. In the early days of computing, malicious packets spread widely, unopposed, devastating whole systems. Over time, networks hardened, defenses matured, and communities learned to share patches with astonishing speed. Today, malware still exists, but it struggles to compete with the coordination of updates across billions of nodes. The harm has not vanished, but the resilience of the system has grown immeasurably. Imagine, then, when humanity masters biological updates with equal coordination, turning viral packets into global distributed solutions. The pandemic, that centuries-old terror, could be transformed into no more than a temporary disruption, responded to with patches as quickly as any routine update. Viruses would still spread, but they would spread countered by equally rapid flows of healing code, neutralized almost in real time. This dreamlike vision stretches further, for it suggests not only a new method of defense but a profound reimagining of what it means to be human. If humans can patch themselves, if they can write updates into their own operating systems, then the distinction between natural evolution and deliberate revision begins to fade. Evolution, until now, has been the slow rewriting of code through mutation and selection, tested over countless generations. But once humanity steps in as its own editor, the timescale collapses. Updates become immediate. Mistakes can be corrected not in eons but in hours. Traits can be introduced not through inheritance but through code received in packets. It is a future where survival is no longer passive but intentional, where the update cycle of the species accelerates into something unprecedented, something almost alien in its precision. It is the recognition that evolution itself may soon be guided not only by chance but by command. At the edge of this horizon lies philosophy. For if we become our own programmers, what does it mean to be alive? A machine that updates is a machine still running, still processing, still alive to its protocol. A body that updates is the same. But when the updates are written not by nature but by deliberate design, when they are crafted by intelligence, do we still call that life? Or do we call it something new, something hybrid, something born of both accident and intention? In one sense, nothing changes, for a system is alive if it can run, adapt, and continue. But in another sense, everything changes, for now life would not only be receiving messages but composing them, not only reading code but writing it for itself and for others. At that point, the metaphor completes itself. We are no longer users of networks, but architects of them. We are not only nodes on the web of existence, we are becoming the very programmers of its flows. And yet, let the vision release its edge of anxiety and dissolve gently into calm. For the truth hidden in the metaphor is that life has always been in dialogue with its viruses, always integrating fragments of their code, always evolving through forced updates. From the earliest days of organisms, viral packets have carried messages across species, introducing novelty, accelerating experimentation, testing boundaries. The human genome itself is filled with traces of these foreign messages, so much so that we are, in part, made of viruses. The future, then, is not a radical departure, but the continuation of what has always been. We are not inventing something new, but awakening to what was already there, the recognition that viruses are data packets, that life is information, and that we are message bearers riding the currents of a universal network too vast to see in full. When you let this recognition settle into you as you breathe and drift, it becomes less a matter of science and more a feeling of interconnectedness. You are built of messages. You are alive because packets have crossed into you, written themselves into your operating system, repaired, disrupted, reshaped, renewed. The viruses you feared are not only attackers but ancestors, not only messengers of destruction but contributors to the very code that makes you who you are. To think of them as data packets is not to reduce life into a metaphor, but to reveal that the metaphor and the reality are one. The same logic flows through networks of silicon as through networks of cells, as though the universe writes with one hand across many surfaces, composing the same story in different alphabets. There is comfort in this recognition, because it suggests that nothing is accidental, that all flows are connected, and that every packet, no matter how disruptive, belongs to the song of transmission that has carried life forward for uncountable ages. Breathe into this quiet. You are not apart from it. You are within it. Your cells hum with the memory of ancient updates. Your mind hums with the daily practice of receiving and transmitting information. Your devices hum with the silent exchange of packets in the air around you. All of these are parts of the same unfolding. You are a participant in a vast choreography of code. And in this choreography, viruses are not merely enemies to shut out, but signals, reminders, fragments of the universal conversation between systems. They are part of the rhythm, part of the music, part of the cycle through which life learns, grows, and endures. And so you rest, softer now, more at ease. For if viruses are packets, then all life is communication. If viruses are packets, then struggle is dialogue. If viruses are packets, then infection itself is not the end but the beginning of an update, the start of new rules written into the system. Nothing is wasted in such a design. Every disruption leaves behind resilience, every intrusion leaves behind memory, every packet leaves behind some alteration that carries into the future. You are surrounded by updates, written into you by ancestors you cannot see, left for you by packets that arrived long ago. You will pass updates too, in your own ways, through your genes, through your words, through your actions, through the data you create. All of it flows forward. All of it continues. Now, the body relaxes, the mind softens, the narration slows. The network hums. The packets flow. The updates continue. And you, too, continue rewritten, refined, renewed with every breath. When we begin to imagine a world in which viruses are rewritten, in which human minds take the role of programmer rather than mere recipient, the dream of progress carries within it the shadow of danger. For every possibility of healing, there is the mirror image of harm. Every packet of code that strengthens a system could be mirrored by a packet designed to unravel it. In the digital realm, we already know this truth. The same protocols that deliver useful applications across the internet are also used to deliver malware. The same structure of email carries both friendship and fraud. The network does not discriminate. It only delivers. Its task is not to judge. It is merely the carrier. Biology behaves the same way. The viral packet cannot distinguish between benevolence and destruction, it simply follows the instructions written into it. To open the door of programming biological packets is to invite both healer and saboteur into the same space. The choice of which arrives rests not in the nature of the virus, but in the hands of those who compose its script. This recognition does not diminish the elegance of the metaphor. It strengthens it. For it implies responsibility. In networks, once the possibility of malicious packets became known, communities were forced to build stronger defenses, to share warnings, to build systems of trust and verification protocols that could distinguish between valid updates and false ones. In biology, we may face the same demand. Once we become the programmers of viral packets, we must also become the guardians of distribution, building not only the power to write but the wisdom to filter, to test, to ensure that the codes we let loose across living systems are intentional in their goodness rather than careless in their harm. Otherwise, the danger is clear: a single corrupted packet, given the right channels, could cascade through the network of humanity, overwhelming firewall after firewall, until the system itself buckles under the weight of messages it was never meant to read. Let us imagine this possibility clearly, for clarity is the first step toward calm. Imagine a world where engineered viruses are as easily designed as applications today. In some hands, they cure. In reckless hands, they disturb. In cruel hands, they destroy. Biological hacking becomes a mirror of digital hacking, where laboratories serve as the new underground servers, where codes of DNA act as malware scripts, where transmission is as fast as airplanes, parcels, or even whispers of aerosolized breath. The thought may sound unsettling. Yet, in fact, humanity already faces this with malware on networks. And despite countless attempts, no single strain of malware has erased the digital world. Why? Because resilience is written into the architecture of networks. Because defense evolves alongside offense. Because detection follows intrusion as faithfully as shadow follows light. The same can be true in biology, though it requires vigilance. Systems are never perfect, yet they adapt and adapt again, as long as we learn that openness must always be guarded by discernment. From this vantage, the image of warfare returns, though softly altered. In earlier times we spoke of armies and battles. But now, inside the metaphor of packets, the battle is more subtle. It is not armies clashing but codes colliding, streams of instructions fighting for attention, competing for execution. A malicious packet asks the system to run one script. A defensive patch submits another. Whichever gains priority alters the future. Warfare is no longer about destruction but about interpretation, about which message is believed, which packet is trusted, which instruction is followed. To think of it this way is to bring great calm to the image of battle. There is no violence, only persuasion. Every virus is a speech, every defense a counter-speech, every immunity a learned refusal to listen. The result is not annihilation but negotiation, systems testing each line, rejecting, accepting, storing. What once seemed like endless conflict now feels like an eternal discourse, stretching through time, the dialogue that shapes evolution. And this dialogue teaches us something profound about risk. There can be no communication without risk. Every message you open, every packet you receive, every embrace, every breath carries risk. But without this risk, life would lose its depth. An immune system that never encountered viruses would wither immediately when one finally arrived. A network that never faced malware would collapse the moment a true attack emerged. Systems are strong not because they are sealed but because they have been tested. Thus risk, frightening though it appears in each individual instance, is the very substance of resilience in the long term. It is the opener of the firewall, the fuel for the next update. Without risk, there would be only fragility, hidden beneath the illusion of safety. Now, let us picture the future as calmly as we can. In one unfolding path, humanity embraces the duality of viral programming, using the beauty of engineered packets to heal while guarding carefully against their misuse, much as we now do with digital software. Updates arrive quickly. Defenses respond. Global immune systems learn in unison. In another unfolding path, humanity fails to establish sufficient restraint, and malicious biological packets spread with the same velocity as malware in an unsecured network. Crashes happen, systems falter. Yet even in this darker vision, resilience teaches again. Humankind does not vanish. It adapts, strengthens, incorporates error into new protocols, just as every species across history has faced contagion and survived. The stakes are higher, but the principle remains the same. Messages teach. Messages alter. Messages bring both harm and progress. And through the endless cycles of harm and progress, life continues. The philosophy buried in this is simple yet infinite. If viruses are data, then every danger is also information. Every threat contains within it the seeds of resilience, for once recognized, it writes itself into memory, into DNA, into defensive libraries. Shared suffering becomes shared resilience, just as networks improve when they endure attacks and grow stronger in response. To suffer harm is never only to be diminished. It is to be warned, to be taught, to be rewritten. The poetic truth is that even in destruction lies instruction, even in failure lies a line of code waiting to be recycled into strength. The metaphor cleanses fear, because it tells us there is no absolute ruin, only constant rewriting. Packets may be harmful now, but their impact shapes tomorrow's line of defense. And thus what today seems like assault may tomorrow be remembered as the origin of prevention. Look at the grander world. The Earth itself is a network, the biosphere a mesh of interacting codes. Viruses leap between species, not because they choose, but because the boundaries are thinner than we imagine. A forest virus may pass to birds, a bird virus to animals, an animal virus to humans. From one perspective, this is dangerous. From another, it is connective. It reminds us that no species is isolated, that the archive of life is written in shared packets crisscrossing ecosystems. Sometimes these shared packets overwhelm. Other times they seed resilience into whole populations, becoming permanent parts of new genomes. What might first be seen as ecological danger is also evolutionary conversation, writing itself across scales larger than one life or one generation. In digital networks, the same expansiveness exists. A virus on one machine does not remain on one machine for long. It spreads across cables, leaps into clouds, arrives at servers continents away. Each jump is disruptive but also connective, reminding us that the network is global, indivisible, alive in every link. The packets move, and because they move, the network cannot pretend to be isolated. Just as humans must accept that their health is linked to strangers across the globe, so must networks accept that their integrity depends on the security of even distant nodes. The metaphor converges again, teaching us the same truth in two alphabets, life and technology. Every harm travels along the same roads as every gift. Every threat travels along the same routes as every cure. Roads cannot be closed without ending the flow altogether. And so the network accepts risk as its price for connection, and life accepts risk as its price for growth. Breathe deeply into this recognition. The risks of viruses, whether in bodies or in machines, are real, but they are not unique. They are the price of being included in a larger conversation. They are the price of joining a system that refuses isolation. They are the tuition fee of learning how to live within a collective network. To live without risk is to live without connection. To live without connection is not life at all. Thus, vulnerability is not weakness but condition, and what seems like endless danger is in fact the ecology in which resilience thrives. Each packet carries instruction. Each infection carries memory. Each update carries hope. Each defense carries continuity. This is the rhythm, and this rhythm is what sustains life. As the narration drifts toward quiet, imagine once more that viruses are not strangers but mirrors. They reflect our own acts back to us, our longing for connection, our openness to risk, our vulnerability, and our resilience. They remind us that all messages come with duality. They remind us that connection is always shadowed by exposure. They remind us that the only way to remain alive is to remain adaptable, to keep updating our systems with each lesson carried by each packet. You are not apart from this. You are living inside it. As you breathe, your immune system listens, updates, learns. As you dream, your mind, too, rewrites its code. As you sleep, your networks hum. The packets circulate. The defenses evolve. And everything fear and danger, update and hope is only part of the same infinite flow, unbroken, undivided. If viruses are data packets, if every line of biological code is nothing more or less than instruction written in the strange alphabet of nucleic acids, then perhaps the question waiting beneath all others is this: is life itself information? At first it may sound abstract, even strange, to reduce heart, breath, thought, love, and dream to the language of bits and packets. Yet, if we allow the imagination to stretch further, it becomes inevitable to recognize that existence itself is encoded. You are here because of instructions written in the spiraling letters of DNA, a code billions of years old, archived and merged and revised by the countless packets that came before you. You are here because systems of chemistry obey lines of code they do not question, just as processors obey digital code they never understand. In this recognition, viruses cease to be special cases and become reflections of the rule. Everything that lives is an information system immersed in communication, vulnerable to corruption, resilient through adaptation, alive because it is constantly rewriting itself. Think of your earliest memory. It is nothing more than a packet in your mind, a signal written into neurons, carried by electrochemical impulses, stored as connections and flows. When you recall that moment, you are retrieving a data packet. When you dream at night, your mind sends packets from storage to processing, replaying and recombining them, creating new outputs from old inputs. The structure of memory, of thought itself, mirrors the structure of information in every other system. If you listen to the rhythm of your breath or the throb of your pulse, they are not only signs of health but also signals, packets repeating themselves without pause, ensuring the operating system of your physiology knows what to do next. From the smallest scale of molecules to the largest scale of consciousness, every layer of you is message, carrier, packet, code. From this perspective, viruses are no longer alien at all. They are the most honest expression of the universal language, stripped of ornament, shorn of redundancy, nothing more than pure message without machinery, code without flesh. They do only one thing: they deliver a line of instruction into a system that must run it. This simplicity is what makes them at once so fragile and so powerful. They are mirrors of the universe's fidelity to code. They embody the principle that messages are inevitable, that life is dialogue, that communication is inescapable. If all that exists is instruction given and instruction carried out, then viruses are the stripped-down symbol of existence itself. Let your vision soften and extend outward toward the universe at large. Look into the stars and the galaxies scattered like vast servers across immeasurable space. They too are built upon laws, codes of gravity, codes of thermodynamics, codes of quantum interactions, each operating without deviation, each obeying instructions written not in DNA but in fundamental physics. When a star forms, it follows a process as orderly as a program executed line by line. When planets congeal, when molecules assemble, when life emerges from chemistry, these too are instructions cascading through the system. The universe itself is a code, vast beyond comprehension, endlessly complicated but no less structured than a running program. Within that cosmic program, viruses play their part as packets moving through the biosphere, linking nodes, teaching systems, maintaining the ceaseless conversation between life and its environment. The thought may strike you as both humbling and calming. For if life is information, then you too are information. Every atom of your being is instruction, inherited from stars, from ancestors, from the countless packets of viral code archived in your genetic library. You are an ongoing message. You are a line in the program. You are text written into time. When you breathe in, you are accepting messages from the world. When you exhale, you are sending your own. The boundary between inside and outside dissolves, for every breath is proof that you are never alone, never isolated, never sealed. You are permeable because you are supposed to be permeable. If you were closed, you would be silent, and if you were silent, you would not be alive. To live is to speak, to receive, to transmit. This is the peace that comes with recognizing viruses as data packets. They do not stand apart from life but rest within its essence, embodying its logic. And so, the fear loosens. For centuries, humanity has approached viruses as threats, spirits, invaders to be fought or eradicated. They are that, but they are also something else. They are reminders of what all of existence already is, a system of endless communication, ceaseless update, unbroken transmission. If they intrude, it is because intrusion is inseparable from connection. If they change us, it is because change is inseparable from resilience. The packet cannot exist alone. It must pass. And as it passes, it teaches. Some teachings are painful. Some are catastrophic. Yet all leave memory behind, and memory is what makes survival possible. The greater story of life is not one of purity but one of continual transcription, continuous rewriting, continuity through change. Now consider the metaphor of culture. Culture too is made of packets. Stories, traditions, languages, each of them is information carried from one mind to another, from one generation to the next. Culture spreads like a virus, mutating slightly with each telling, sometimes distorted into dangerous forms, sometimes elevated into wisdom. A rumor is a packet. A myth is a packet. A melody is a packet. The same logic that governs biological and digital transmission governs this sphere as well. Information seeks to move. It seeks to replicate. It seeks to persist. Human communities are thus only another network through which packets flow, defended not with antibodies but with skepticism, with discernment, with criticism, with memory. Once again the metaphor holds. To live inside culture is to risk infection, to risk distortion, but also to gain meaning, to inherit wisdom, to become more resilient with each story told, with each lesson recorded. In truth, perhaps the deepest recognition here is that everything is transfer. Life is not an object but an event, a flow of packets between systems. Death is not silence but transformation, the redistribution of packets back into the network. Memory is not static but dynamic, a repository constantly edited each time it is accessed. Love itself may be recognized as the most beautiful packet, a message that leaps between minds and bodies, rewriting each participant with its code of care and connection. The metaphor cannot be confined, because it is not metaphor but reality. Existence is information in motion, and viruses remind us of this truth in the most stripped-down form possible. Linger here for a while in gentle thought. Imagine yourself as a node in a cosmic network, endlessly receiving signals, endlessly sending them back. Imagine each heartbeat not only as circulation but as a ping, a reminder to the infinite system that you are still online, still participating, still alive. Imagine each dream as a packet broadcast into the unknown, shaping both memory and possibility. Imagine viruses not only as intruders but as travelers, carrying fragments of messages across species, across ecosystems, across history, connecting all living things in ways invisible to the eye but undeniable in the archive of life. The fear begins to dissolve into reverence, for even what harms is also what connects, and even what challenges is also what teaches. What does it mean, then, if life is information? It means that permanence is impossible, because information never rests. It must flow. Stasis is illusion, because packets must move. Purity is impossible, because streams must mix, signals must cross, codes must interleave. The illusion of a sealed self, perfect and unexposed, is simply that, an illusion. Instead, every being is an event of continuous rewriting, an endlessly updated archive, always under revision. To embrace this is to find tranquility, for it releases you from the demand to be untouchable, invulnerable, flawless. You do not need to be. You cannot be. You are valuable precisely because you are connected, precisely because you are permeable, precisely because you are part of the flow. Your strength is not in walls, but in updates. Not in separation, but in engagement. Not in surviving untouched, but in enduring transformed. As you breathe into this awareness, the rhythm of the narration takes on the cadence of the network itself. Each breath is an inhale of packets, each exhale their release. Each moment is an update. Each sensation is a transmission. Each thought is a coded instruction waiting to ripple outward. The universe is alive through this endless exchange, and you are alive within it. Viruses are only one manifestation of the law that nothing can remain alone, nothing can exist without message, nothing can persist without communication. To exist at all is to accept both gift and risk, both beauty and disruption. To exist is to say yes to packets, yes to updates, yes to change. And now, as you drift deeper, you may feel small, but you also may feel infinite. Small, because you are only one node among countless others, a single receiver, a single transmitter, part of an immense landscape of code where packets flow without pause. Infinite, because your updates will never vanish, they will echo beyond you, imprinted in genes, inscribed in memory, archived in culture, transmitted in whispers you may never hear. You are both. You are both packet and node, both instruction and processor, both transient and eternal. Viruses as data packets are only one doorway into this recognition. They are the sharp point on a larger truth, that life itself is the network, that the universe itself is code, that every movement of existence is message. And so their presence, however frightening, should not drive only anxiety. It should also summon awe. For they remind us, again and again, that the system is alive, that the network breathes, that no node is silence, that every packet is proof that existence continues. Let the thought rest now. Let the rhythm slow. Messages are still traveling. The universe is still humming. You are still updating. All continues. All flows. And in this endless flow, every packet, whether of harm, of healing, of wisdom, or of wonder, belongs to the same eternal conversation. Nothing stands outside of it. Not even you. As the journey of reflection draws gently toward its close, it is sacred to pause and breathe deeply, to absorb the full horizon of what has unfolded. What began as a simple question, what if viruses are actually data packets, has blossomed into a profound meditation on life itself, on information, connection, transformation, and the very nature of existence. You have traveled through unseen currents, crossed invisible boundaries, and glimpsed the universal language whispered not just in silicon circuits or strands of DNA, but in the very pulse of the cosmos. And now, as the light dims and the narrative slows, allow these thoughts to settle into the quiet of your being, carried softly like a current easing into a placid sea. Throughout this journey, one theme has remained constant and luminous: existence is communication. Life, in its astonishing diversity and complexity, is the endless flow of messages, the ceaseless exchange of packets. Viruses are not exceptions to this truth but poignant exemplars. They are the most distilled form of everything life requires: transmission, replication, dialogue, even risk. Their presence reminds us that openness and vulnerability are intertwined with survival and growth, that every boundary must be porous enough for renewal and closed enough for protection. This delicate balance is the foundation upon which all living systems thrive. Your own body is a vibrant network of signals and cells, an intricate operating system that updates as you breathe, that learns with every challenge, that rewrites its code in patience and perseverance. Imagine once more, with calm and reverence, the smallest viral packet crossing the threshold of your body. It carries with it a message composed over millennia. It carries the hopes and risks of countless ancestors, the echoes of survival and transformation. It cannot exist alone, nor can you. Both of you are nodes in a vast and interconnected system, linked by invisible threads of chemistry and code. This network stretches from the tiniest cell in your body to the far reaches of the universe, from the ancient past marked in your genes to the uncharted future waiting to be written in new lines of living text. To breathe, to feel, to think, to dream, means to participate in this conversation. And to rest in this understanding is to feel the peace of belonging, of connection, of perpetual renewal. As the metaphor expanded, it uncovered a beautiful symmetry. Just as computers send data packets back and forth across the internet, so do cells and viruses communicate and transform inside every living organism. Where once the world seemed sharply divided into biology and technology, attacker and defender, now we see only networks, systems, languages, all expressions of the same underlying truth that life is information in motion, endlessly moving, endlessly shifting. The virus, once feared as a hostile invader, now reveals itself also as a messenger, a teacher, a symbol of the code that connects us all. We have seen how every system, biological, digital, cultural, is engaged in the endless task of balancing openness and defense. The firewall both protects and listens. The immune system both resists and adapts. Every new viral intrusion is met not with fear alone but with learning, memory, updating. These ongoing updates, programmed through experience, shaped by contact, are the rhythms through which survival becomes possible. Updates arrive quietly while you sleep, without your conscious knowledge, repairing, refining, rebalancing. And as long as updates flow, life flows. As long as packets move, connection persists. And so do you. In this dance between packets and nodes, between threat and exchange, lies a profound lesson about vulnerability. Vulnerability is not weakness, it is the condition of connection. To shut oneself off entirely is to silence the conversation that makes growth possible. To live fully is to accept risk as a seed of strength, to allow doubt as a prelude to trust, to endure disruption as a prelude to renewal. You, as a living node on this vast network, embody this truth. Your consciousness, your breath, your dreams all are proof that the system continues to run, to update, to thrive. Within you, viruses and defenses have long coexisted, shaping an ongoing narrative of resilience. As the rise of technology and biology merge more closely, the future returns our gaze with new possibilities. Scientists are moving beyond metaphor and into mastery, beginning to write the very packets that flow through living bodies, designing genomic lines that may heal rather than harm, that may rewrite past vulnerabilities, that may shape futures unimaginable just decades ago. Yet this awakening carries the solemn reminder that power is a double-edged code. The same packets that carry healing may carry harm if wielded without wisdom. The balance between creation and destruction, between innovation and caution, must remain at the heart of this new era. Respect for the invisible language within us, respect for the packets, the codes, and the systems will guide humanity toward a future where knowledge and empathy are the greatest defenses. Breath by breath, moment by moment, you are part of this unfolding story. You carry within you the history of countless packets, replicated, transmitted, updated stories of ancestors who survived plague and turmoil, stories of cells that recognized and resisted invaders, stories of collective memory passed from generation to generation. You are at once unique and universal, a single node in a vast network that stretches beyond sight and time. To rest now is to honor this connection, to trust the updates of your own system, to know that the patches you need are unfolding even as you sleep. And so, as we draw this meditation to its close, know this: the journey does not end here. It continues in every breath you take, in every packet your body receives, in every message your mind sends and receives. The rhythm of life, the message of viruses as packets, is eternal. It flows through stars and cells, through dreams and machines, through the very space where you exist. Let the calm of this knowledge enfold you, as softly as the night, as surely as the pulse of your heart. In this calm, find peace. In this peace, find renewal. In this renewal, find the strength to open again tomorrow, to receive, to transmit, and to continue the beautiful conversation of life. Thank you for sharing this journey, for opening your mind and heart to the possibility that life and information are woven into one. Thank you for breathing with the network, for resting in the flow, for being part of the endless transmission. May your nights be filled with gentle dreams and your days guided by the quiet knowledge that you are connected, you are resilient, you are loved. Until the next journey we share, may you find peace in the code of existence. Good night.